I'm sorry, people. I have to adjust the camera because every time if I live stream, yeah. Anyway, how are you guys doing, ladies and gentlemen? How are you guys doing? 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 All right, so let me also get a chat right here. So just give me 1 sec. I want to make sure that things are okay. I haven't done this for a while. Huh. Let's see. You guys can take a guess that how I am doing the streaming. Right? What device am I using for the stream? Yeah, but I'm just it didn't come out. Anyway. Cool. So we have 14 people right now, 16 people. Okay, I can see the chat now, and let me just hear if the voice. Okay, I can see the chat now, and let me just hear if. Oh, perfect. Okay, cool. Okay, so let's get started. Today we'll be doing my exam number 1 for my Calculus 2 class, and of course, you guys can go download the file. The link will be in the description for your convenience. And thank you so much for congratulating me for the 100K. Thank you. Hello everybody. Hello everybody. Oh hey Adam, how are you? How are you? How are you? Right. So let me just adjust the camera one more time, just a little bit, because yeah, I don't want to show like my kitchen part. All right. So maybe this is better. Okay. So I am kind of happy with this now. Okay. If you are my Calculus 2 students who I sent out an email yesterday, right? You can go ahead and let me know. Drop your name down, and then yeah. You know what I was going to do? I was going to erase the things on the board, but if I do that, then that will be pretty. That'll be like my stupid act, like caught on camera, because these are the first two questions. Anyway, as usual, for my calculus exams, right? My usual mix is 6 multiple choice questions and then 7 questions that you have to show work. The link to the file is in the description, and you can go ahead and try the questions. And here will be the solution for that. All right, so for the first question, we have the integral 1 over x squared plus 2x plus 10. Unfortunately, this right here cannot be factored in, right? So, we'll see. And this is not factorable because it's actually irreducible in the sense that we cannot use real numbers to factor it. So the way to do this is that we just have to complete the square. And let me just do that right here for you guys. If we take a look, so this is by completing a square, x squared plus 2x, and we are going to leave a space, and then let's put down a plus 10 here. And for this number, we are going to do half of this, which is going to be just 1, and then we have to square that, so it's just 1. So we're going to add 1 right here, and I call this the magic number. But don't forget that after we add the 1 right here, we will have to minus 1 right here. And you see that this number is so magical because after we add this number, the first 3 terms will be a perfect square. So in fact, this right here becomes x plus 1 squared, and then of course this and that is just plus 9. So that's actually a numerator. So that's actually a denominator, and then this right here, we can just look at, it's the integral of 1 over this for the bottom. And here we get x plus 1 squared, and then plus the 9, we are going to look at that as 3 squared, because this is going to be a inverse tangent answer, right? And then we have the dx. And right here, you can just do a u sub real quick, but the u sub actually doesn't matter that much. Because if you let u equal the inside, which is x plus 1, then you see du is the same as just dx. So there's no like extra numbers to divide whatsoever, so you can actually just proceed. The answer is going to be, we'll use the inverse tangent formula, namely 1 over the a value, which is 3, and then times the inverse tangent of the input right here, which is our u, which is just x plus 1, over the a value, again 3. So that would be the first question right here. So plus C. And then you guys can take a look at my answer choices in the file, because I also have like ln of the bottom, or maybe do some like weird partial fractions. You guys can go ahead and check that out. I love writing multiple choice questions. All right. In fact though, so for my students, you guys should know this is actually from the homework. So if you guys did the homework, then you should know that's from homework. Okay. Let's take a look at number 2. I want you guys to try this first. Which of the following is false? So I'm saying the integral of secant square x is equal to tangent x. Next, integral of x squared is equal to 1/3 x plus third power. And then next, integral of 2 to the x is equal to 2 to the x ln 2. Next, integral of 1 over x squared is equal to negative 1 over x. And lastly, integral of 1 over x minus 1 minus x is equal to ln absolute value of 1 over 1 minus x. Of course, they all have the plus c. So now, go ahead and try this. Which one is false? Which one is false? Which one is false? Which one is false? Yeah, which one is false? I'm going to just step aside. Which one is false? I'm looking at the computer, so that's how I can see your chart. There's only one answer. There's only one answer. This one threw off a lot of my students. That they were asking me like, Mr. Cha, are you sure that there's nothing wrong with the question for number 2? Yeah. There's only one answer. Ladies and gentlemen, the answer is B. No, just kidding, of course. Yeah, of course. Didn't look. Yeah. C. All right. Okay, so the integral of 2 to the x. You are supposed to be dividing by the ln2. So I'll just make a correction right here. This correct answer is supposed to be 2 to the x over ln2 and then plus c. So that will be the correct version for that integral. A lot of my students, they will ask me like, isn't there something wrong right here as well? No. All right, here's the correction. If you look at this right here, right, you can use the formula, the integral of ax plus b. You get 1 over a, so you have the negative 1. So just pay attention right here, we have the negative 1. All right, negative 1. So you divide it by negative 1, you have negative, and then you have ln, absolute value of the bottom, which is just 1 minus x. Right, so that's pretty good. But you see, this is actually negative 1. What we can do is, we can put this back to here and make that into an exponent. So we get ln absolute value, and we are getting parentheses 1 minus x raised to the negative 1 power like so. And if you look at this raised to the negative 1 power, of course you can look at this as ln absolute value and bring that down to the denominator, 1 over 1 minus x like this then, and then put on the plus c. So in fact, this right here is 100% legit. And we did this right here when we were integrating the tangent x function. So yeah, you should just kind of remember that little move. And in fact, later on, once we study sequence and series, I will tell you guys that 1 over 1 minus x is, our best friend when we are doing the infinite series. So the integral of the best friend is actually the same as the ln of the absolute value of the best friend. All right, so that one. Okay, so these are the first 2 questions, and now let's move on. Did anybody try number 14? You guys can take a look at the questions first. And again, I will be doing live streams about calculus on this channel from now on, because I want to just make this channel like all about calculus. All right. So number 3, we are doing a trig sub question. We are looking at the integral of x to the third power over the square root x squared plus 4 and then dx. And it's given that you have a Pikachu, which is right here, And Pikachu is actually going to use tricks for this. And the substitution is x is equal to 2 tangent theta. So our goal is to just do the necessary things and then plug in and see which integral do we get in the theta world. So as usual, we differentiate both sides. Dx will be 2 secant square theta d theta. And plug in. So we get the integral. This x has to be replaced with that. So we get 2 tangent theta and then to the third power over. We have the square root. And then we have another x here. This right here also has to be replaced by that. So we just have 2 tangent theta and then square. And then we add the 4. And then the dx is that. So remember to put this down as well. 2 secant square theta d theta. So this integral now is in the theta world, like completely. And now we just have to do some simplification. So as we can see, let's do this in blue. On the top, 2 to the third power, and then tangent to the third power. So this is what we have. And then on the bottom, you see this right here is 4 tangent square theta plus 4. But we can factor out the 4, and then we get the tangent square theta plus 1. And this right here is nicely equal to secant square. So we have 4 secant square theta. But remember, everybody, right, all this right here is instead of the square root. And right here, we just get 2 secant theta on the bottom. And again, as I said, you don't need to worry about the absolute value. Just focus on the integration for all this. And now we can just do some cancellations. So let's see. Notice that the 2 and 2 cancel out very nicely. And this right here is secant to the first. Cancel out one of them, so we have one more power right here. And if you look at the top, we have 8 tangent to the third power theta and then secant, right? So that will be the answer. Well, because again, I just want to ask you guys to take this integral to the theta world. So we will have the integral 8 tangent third power theta and then times secant theta, and we are done. So this is the integral that you should be getting in the theta world. So that's how my question is written. So you guys can take a look. Yeah. So it's not because I didn't finish the integrating all that. It's because this is how I want to ask the question. All right, number 4. I can actually squeeze in number 4 right here. Not so bad. So integral of 1 over square root of 2x plus 1 dx. This right here is pretty nice and easy, huh? Do a u sub, let u equal the bottom, which is 2x plus 1. And we see du is equal to 2 dx. So that means dx is equal to du over 2. Take this integral to the u world. This is integral 1 over square root of u. And dx is that, so du over 2. Put the 1/2 in the front. We have it right here. And then the integral, look at this as u to the negative 1/2 power in the u world. Okay, right here, add 1 to the power. The new power is 1/2 divided by the new power, which is the same as multiplied by its reciprocal. And you see this and not cancel. And we just get u to the 1/2 power, which that's just the square root. But we know that the u right here is that. So we just have 2x plus 1. And then we are done. We put on the plus c. And then this is it. All right. So the first 4 questions. Not so bad, huh? So this channel is supposed to be for all the students who are taking calculus. So I wanted to know, now what calculus are you guys taking? So you can leave it in the chat and let me know. What calculus are you guys taking? I didn't forget the plus c, right, did I? Actually, I forgot about if I put on the plus c or not. No, that's kind of bad. Cool. If you're taking Cal 2, then this is definitely for you. And what are you guys doing right now? You should be finishing integrations already, and then you should be doing some like improper integrals by now, right? That's just my guess. It depends. And if in Calculus 1, I was drawing some Calculus 1 videos here and there, but in this semester, I'm teaching Cal 2, so you'll see a lot of videos will be just going with my current course. Thank you, Adam. Pre-university calculus, okay. Self-taught, okay, cool. Yeah, and let me know if you guys have any questions. You can always leave it in the comments and let me know. Alright, so now let's look at number 5. Again, a very standard question. Integral of inverse tangent x dx. And oh my god, this one. I just like to put this question on the test because every time, right, I will see students just say the answer is 1 over 1 plus x squared plus c. What's wrong with this? What's wrong with this? Anyone? This is a super common mistake. What's wrong with this? No, what's wrong with this when you just put down 1 over 1 plus x squared? I'm looking at the answer. If you get it right, I'll give you a shout out. Yeah, so okay, so your name in English is Phoenix, right? So I'll just say Phoenix. Yeah, you got it right. This right here is the derivative. We are trying to do the integral, so don't do this. It's an extremely common mistake, and especially when students are doing integrals a lot, they kind of miss derivative. So when they see that, they just put on the derivative. Yeah. But now you know, don't do that. Otherwise, this is 5 points, then, that might potentially change your letter grade. So don't do that, of course. The way to do this is we do integration by parts. And the reason or the hint that you should be doing integration by part is when you are trying to integrate an inverse function, most likely integration by part is the way to go. Of course, we'll do the di, put on the plus minus. I'm not going to integrate inverse tangent. That will defeat the purpose. So I will actually differentiate inverse tangent, and then I will just have to integrate 1. Now, this is legitimate. We differentiate inverse tangent, we get 1 over 1 plus x squared. And then when we integrate x, sorry, that's the answer. When we integrate 1, we get x. And now you see this times this is the first part of the answer. So we get x times inverse tangent of x. And then we are going to multiply these two things together. Put that inside of the integral, and that's going to be a minus because negative times positive. Put that inside of the integral. This times that, so we can just write it as x over 1 plus x squared. Okay, by now, you guys should be an expert of doing U sub, especially for a nice question like this. Let u equal the bottom. So we'll do this everything inside our head. Let u equal to the bottom right here. The derivative of this is 2x. On the top, we only have x. We need a 2. So what we can do is just go ahead and multiply this by 2. But if you do that, don't forget to divide it by 2 as well. So this right here can be looked at as the integral of 1 over u in the u world. So now, we can just write down the answer. This right here is x times inverse tangent of x minus 1 over 2. And then this right here is ln of the denominator, which is 1 plus x squared. But since this is always positive, we just need a parentheses and then we are done. Put a plus c, that's it. And if you still need to write down like the u substitution steps, go ahead and feel free to do so. And I still think that you will still have to know how to kind of skip the little u substitutions, because otherwise, calculus 2, like some of the problems will be just too long if you have to show every single steps. So that's why I didn't show the steps for that one. Number 6. Thanks for, yeah, I cut it over the weekend. I did it by myself, by the way. It's super easy for half year students, like haircut like this. Okay, number 6, integral ln x over x dx. All right, so for this one, we can also do u substitution. If you would like, you can actually do integration by parts for this as well, but u sub it's much easier. So I will show you guys the steps right here. U is equal to ln x. Du is equal to 1 over x dx. So you can see we do have the du right here already. So in fact, we are just integrating. This is the u, but if you look at all this, that's exactly 1 over x dx, which is the du. So we just get 1/2 u squared for the integration, and the u is that, so it's just ln x. And then square that, put on the plus c, and this is it. Josh, you said you did this by taking the derivative of each option. You mean for number 6? That's a great idea. Yeah. Yeah, one way or the other, because they aren't so bad, right? Okay, so let's continue. Now we are getting into like the slightly longer questions, because for the shorter questions, usually I ask for like longer questions. My favorite multiple choice questions, the format is which of the following is false, or maybe which of the following is true. Like, that's my favorite type. As a teacher, not as a student. If I am a student, I wouldn't like a question that asks me which of the following is true or which of the following is false. Yeah, but just a little secret to share with you guys. I hope my students they don't hear that, but they should be here. I don't know, because this is kind of like a time that people will be taking classes. But I only have time right now because later on I will have to teach at 3:30. So yeah. Okay, second page. Thank you. Thank you. Okay, number 7, integral of cosine to the 5th power x. So this is a typical trigonometric integral, and we are dealing with cosine. So this is to an odd power, so it's actually not so bad. We can actually just put one of the cosine out and then try to convert the rest in terms of sine, and then we can just do stuff on that. So we'll see. Let's write it as cosine to the 4th power x and then times cosine to the 1st power x. So that will still give us cosine to the 5th. But for this right here, we can look at this as cosine square x and then raised to the 2nd power, right? Because remember, we love to see cosine to the 2nd power because we can use identities for this. And because we have the cosine x right here, as we mentioned earlier, we want to write this in terms of sine x. So the identity that we'll be using is this equals 1 minus sine square x and then raised to the 2nd power, and then we have the cosine x. So that's the idea. Now from here we can just do u sub, let u equal sine x, and we see du is equal to cosine x dx, which is this right here, and that's very nice. Because now we can just look at this integral as the integral 1 minus u square, and then square, don't forget this is another square, and this guy is just our du. And now to integrate this, we just open that, so we are getting the integral 1 square first, which is 1, and then minus 2 times this and that, which is just 2u square, and lastly we add this term square, which is u to the 4th power, and then du. Yeah. Okay, so this is good. And now I want to just take one more step because I want to show you guys that when we integrate 1, but in the u world, be sure you write it down as u. Integrating 1 in the u world, we actually get u. Some of my students put down x, which is of course incorrect. So let me just put this down right here, and then we have minus 2u square. Sorry, no, I have to integrate that. I have to integrate that, so it's going to be you add 1 to the power, which is 3, and divided by 3. So we get minus 2 over 3 u to the 3rd power, and then plus integrating this, we get 1 over 5 u to the 5th power. And usually people will tell me to put down plus c right here, but no, I will just put down a plus d at the very end. So right here, let's see. Let's go back to the x world. U is sine x. So we have sine x, and then the rest is the same thing, like minus 2 over 3. And when we see u, we just put down sine, and this is to the third power, and then plus 1 over 5. And we have sine x to the fifth power plus c. All right. So this right here will do it. For this one, it's really straightforward, so I didn't let you guys guess the method. So yeah, you have a good point. Yeah, so yeah, I will do that for the next one. But for this one, it's just rather typical. All right, so there are some integrals that once you see it, you know what to do, right? Like for example, this one, it's actually not so bad. And in fact, the next one, you should know the method right away as well because of the form. So I wouldn't consider, those kind of questions hard. I will only consider the questions that when we see it, it's like, I don't even know what to do. That might be hard. So next one, let's see, we have this, number 8. Integral x plus 3 over parentheses x minus 1 and then x minus 2 squared dx. Again, because of the form, this right here, it's also not so bad to know what to do to start. So I'll let you guys tell me then, what do you guys think? And again, when I'm looking at this direction, I'm looking at your chart. So what do we do to take care of that? Partial fractions. That's it. That's really it. Because you can see the form, right? And thankfully the bottom has been factored in for us already. So this is totally a partial fraction situation. Notice that the degree on the top is 1 and degree on the bottom is 1 and 2, so it's 3. So we don't have to do long divisions. We'll just have to do it. So this is one of the slightly longer question on the test, but it's actually not so bad. Anyway, I'm going to write this down right here for you guys. So we have x plus 3 over parentheses x minus 1, x minus 2 squared. Notice we have this to the second power. This is a repeated linear factor case. So when we break it down, we are going to get the first fraction will have this for the denominator, and on the top, because this is linear, so we just have a constant, let's say a. Next, for this right here, we will have to build up our power, starting with x minus 2 to the first power, and then go up to the second power. So we have x minus 2 to the second power. Whenever we have a repeated power like this, right? Repeated factor, you always have to build out the power. If this is 5, you just have x minus 2, x minus 2 squared, x minus 3 squared, x minus 2 to the third power, x minus 2 to the fourth power, x minus 2 to the fifth power. But I won't ask you guys this kind of questions on the test. And anyway, when we build out the power, the top stay the same kind. So you see this right here, it's a linear, right? So on top is just going to be a constant, let's say b. And if you look at this, it will be the same kind, so it's just a constant, but it's just maybe another one, so let's put down c. This right here will be the partial fraction form, the setup for it. All right? So for this right here, we'll just do the work. But thankfully, we can actually use the cover up method to solve for 2 letters. Which 2? We can use the cover up for 2 letters. Which 2? So maybe you guys can help a little bit too. The cover up. This is the fast way to do partial fraction. If you use the cover up, your life will be like 2 letters happier. C we can use cover up because we have this right here, the same denominator, so that's a good choice. But what else can we also use cover up? Namely, the easy way to do partial fraction. Yes, you're right. We are going to use cover up for A and C because you see the denominator right here, and that's exactly the same denominator, and then right here, same exact denominator. So we can use cover up to get a and c. Let's go ahead and do that. And that will give us a equals, to figure out 8, look at the denominator, which is x minus 1. We go back to the original, cover the same thing. And you ask yourself, how can we make x minus 1 0? X has to be 1. So we have to put x is equal to 1 into the rest of the x's. So we put 1 in here, we get 1 plus 3 over, we put 1 in here as well. So we have 1 minus 2 and then square. Work that out and don't make any mistakes like I do. Yeah, because I did a video on this, I just couldn't figure out like the arithmetic mistake for the longest time of my life. But anyway, this is 4 over positive 1, so a is equal to 4. Good. Now let's look at c. We have the same denominator, we can cover this up, and x has to be 2, because 2 minus 2 will be 0, so we have to let x is equal to 2. And then we put 2 into this and that x. So we get 2 plus 3 over 2 minus 1. And this right here is 5. Good. So we know c is equal to 5. And that's actually pretty good. Now, to get b, I usually recommend my students to just do the classic way because that's perhaps least confusing. If you want to do it fast way, maybe you can just plug in x is equal to 0. But I tried it and a lot of students didn't like that, so I'm just going to do it with the classic way. And that's going to be multiplying with x minus 1 and then x minus 2 squared. Multiply that throughout the whole equation. So let's see, this is going to give us x plus 3, that's equal to, this times that, the x minus 1 cancel. We have 4 right here times that, so it's 4 times x minus 2 squared, and then continue. One of this cancel, we have the b, so put on plus b times all that, which is x minus 1, but only x minus 2 to the first power, because one of them cancel already. And lastly, we have this, which is plus 5, and then this and that cancel, so we just have that, which is x minus 1. Okay, and then let's just go ahead and work that out. So right here, this is, let's look at this. This is just x squared minus 4x plus 4. Distribute, we get 4x squared minus 16x and then plus 16. Good, and then this right here is going to give us x squared and then minus 2 minus 1, so minus 3x and then plus 2. So we get plus bx squared and then minus 3bx plus 2b. And then lastly, just put that down, 5x minus 5. You probably didn't need to write down all this, but whatever. Because in fact, we could actually stop right here. Notice on the left-hand side, we do not have x squared term, right? So this means that we have 0x squared. But on the right-hand side, we see that this and that, they are the only two x squared terms. So we must have parentheses, this plus that, which is 4 plus b. And then we have the x squared, that's factored in and put it on the outside. And then seriously, the rest, we don't really care. Because now we can say, this and that have to be equal. So that will tell us 4 plus b has to be equal to 0. And that means b has to be negative 4. Yeah, so not so bad. Okay, so b is equal to negative 4. Cool. So do you guys want to check my arithmetic for me? Because especially for this right here, if I make an arithmetic mistake, it's not going to be fun from here. Yeah. Oh, so in AP Calc BC, they only do the non-repeating. But for this right here, once you get the form, then the rest is just some typical algebra for that. So in fact, all this part right here is just the algebra. And one of the reasons why people don't like partial fraction is because it is so much algebra being involved right here. Okay, we're not done yet though, because we still have to integrate. So here we go. Ladies and gentlemen, this right here is the same as integrating. And let's put this down. 4 over x minus 1. And then the next one is minus 4, so we'll put down plus minus 4 like this, over x minus 2. And then for the third one, we have 5, so we just put down plus 5 over x minus 2. And then we square that, and then we have the dx. And technically, I should put down parentheses, but you guys know I don't really like to. But anyway, right here, do this right here. So the constant multiple stays 4 and then ln of the bottom, right? Absolute value, we have x minus 1. Next, we have minus 4, ln, negative 4, and then ln absolute value of x minus 2. And then for this one, I will just do this for you guys real quick. The integral of that 1 over x minus 2 square dx. Sorry, the dx doesn't look so nice. Do the u sub real quick if you would like. Let u equal the bottom inside here. So x minus 2 du is equal to dx. And in fact, this is the same as integrating 1 over u square in the u world. So this right here is the same as integrating u to the negative 2 du. You add 1 to the power, which is negative 1, divided by the new power. So in fact, we get negative, and then we get u to the negative 1. And that's just 1 over u. So I'll put on 1 over u. U is x minus 2. All right? So for the last part, we will have plus, and then we have the 5 multiplied with that. Sorry, it shouldn't be a plus. We have the 5. And then multiply with this. So that's negative. So let's just write that down. Negative. And then we have the 5 over that. So the last one right here, it's not ln anymore. So just be really careful with that. In fact, this was on question number 2 as well, right? For the integral of 1 over u squared du. So yeah. But anyway, that's what we have, and multiply by 5. And we're done. And we can be happy because we finally finished the partial fraction question on the test for that. Usually I just asked for like maybe 1 or 2 partial fractions questions. So yeah, just like that. Okay, any questions? How are you guys doing so far? So this is like a class, 35 students, just like what I usually teach for my actual class at my school. Yeah, via Zoom or in person. Okay, so Kevin, you have a question. Generally, why is integration so much harder than differentiation? The reason is because you can always differentiate, just follow the rule, and it becomes just like a routine. You can always use the product, the quotient, the chain rule, power rule, things like that. But for integration, the problem is there are times that you cannot integrate a function. So perhaps that's one of the reasons why that makes integration so much harder. That's why solving an integral is like an art. Yeah, it's not routine at all. So I think that's one of the reasons why. And of course, there are so many methods being involved and so many tricks, so many things you have to pay attention to. And in fact, if you make this, let's say x to the third power, oh my god, this question will take us maybe like 1 hour or so, 2 hours. Or maybe like, I would rather just give up if I have a 3 over here. So yeah, but if I have a 3 right here, I can still differentiate if you are talking about that. Yeah. Okay. Yeah, I think in general, I agree with Adam. When you do things backwards, like that's usually harder than if you do things forward. Such as when you multiply 2 numbers, it's easy in the sense that you can always do it, right? Just do it. But if you want to break down a number into the product of 2 numbers, if you have to factor a big number, that will be much more difficult. So same idea. But that's what math is, I think. Yeah. Okay. All right, number 9. Integral of sine of ln x. So what do we do for this? Let me see if you guys want to try this first. What do we do for this? This one is integration by parts plus adding over the original integral. Yes, you're right. This is like a repeating situation for integration by parts. And I personally would think that do a u-sub first will be easier. So let's actually do that. Especially when you have things inside, then you have like some inverse functions. Let's try to do u-sub first. Let u equal ln x. And we see if this is true, this means x is equal to e to the u, because that's the inverse function property, right? U is natural log of x. That means x is just equal to e to the u. You can do e to the power on both sides. Do this because now we can have dx equals e to the u du, because we can just look at this and differentiate. And now let's take this to the u world. We get the integral of sine, and the input right here is u, and then dx is just e to the u du. And let me just take one more step, because I personally like to have the exponential functions goes first before the sine, cosine, and things like that. So this right here is the integral, and then we have e to the u sine u in the u world. All right? How do we do that though? Well, we need to use integration by parts. Whenever we have e to the u times sine or cosine of u, and sometimes you might have some coefficients here and there, you do integration by parts. And this will be a repeating case, namely the third stop in my DM method video. So let's go ahead and do that, perhaps right here. Okay, yeah, let's do it right here. D and I, not P, D, plus, minus, plus, minus. Let's see how many times we need. I'm going to just differentiate e to the u. I'm going to integrate sine u. It doesn't matter which one you differentiate, which one you integrate. You can switch them and the answer at the end will still be the same. Because you see, if you differentiate e to the u, it's just always e to the u, which is very nice. Integrating sine u, we first get negative cosine u. Do it again, we get negative sine u. And of course, we can also keep going forever, right? But we need to know when to stop. Notice here we have e to the u and also sine u. You see the function parts repeat, right? E to the u, sine u. We don't care about the coefficient, just the function part. In that case, we are going to stop right here. So in fact, we didn't need the last row. Now this is great because this times this is the first part of the answer. Likewise, we have the second part of the answer. And then don't forget that we still have to multiply these two things together and put that inside of an integral. Whenever we have an integral that's repeating, right, for the integration by parts, let's just go ahead and write this down again. So we have the integral. We have e to the u sine u. Actually, I may need more space. Integral e to the u sine u du. This right here is equal to this times that, which is negative e to the u cosine u. And then this times that becomes plus e to the u sine u. So far, so good. Lastly, this times this is a negative, but when you multiply two things in a row, you put that inside of an integral. So it's a negative integral, and then you have e to the u sine u du, just like that. So now, you see, we have this and that. We can just move this to the other side, and we'll just add this on both sides. So we add e to the u sine u du in the integral on both sides. So let's go ahead and do that. Oops. So this is like the part that you should just kind of do really fast, and then this and that cancel. Okay. This is one integral plus another one. We have two integrals. So this is 2 integral e to the u sine u du, and it's just equal to all that. Negative e to the u, and then cosine u plus e to the u sine u. Wow. All right. And lastly, of course, we don't want to have the 2, so let's just multiply everybody by 1/2. Perhaps this is easier, so that you can see this and that cancel. Integral e to the u, sine u. Ladies and gentlemen, we just get negative 1/2 e to the u cosine u plus 1/2, right? Distribute the 1/2, of course. And this is my u. And then just finish that. E to the u sine u. Wow. But, we are not done yet. We are not done yet. We are not done yet. I don't know why. YouTube puts like u sub like on hold. So if you enter u sub, your comment was on hold. I had to manually approve it. That's weird. Can we skip u sub? You could, but it may not be so clear to some students. I think once we get to the U world, it might be just easier because we recognize this more. So that's why I usually just do it like this. Yeah, but if you skip u sub, if you differentiate this, the differentiation might be kind of not so friendly, I would say. You can try it definitely. But anyway, this right here is equal to that. So we just have to write down the answer. So first off, we have negative 1/2. And then e to the u, well, e to the u is our x. So this guy is x. Right? E to the u is x. And then next, we have this u, which is the ln x. So we have cosine of ln x. And then continue, plus 1/2 e to the u. So we add 1/2 e to the u, again is x. And lastly, we have sine u, and the u is ln x. So we just multiply by sine of ln x. And then we are all done, put down the plus c. This right here is the answer. Cool. So have a look, have a look, have a look. So I personally would think that number 8 and number 9 are a slightly longer question. But if you have done similar practice questions before, which if you're my student, you should know how to do this, because I gave you guys these questions for homework, right? Similar questions, so they shouldn't be a surprise. All right, continue. By the way, I should also mention, if you are taking Cal 2, right, when you are doing integrals, there are only so many different types of integrations that we can ask on the exam. So if you're willing to do enough practice questions, you'll be really good at integrations for your exams or the topics that you guys cover in class. However, if you're trying to do like MIT integration B, then that is going to be a totally different story. You will just have to do a lot more and then see the things that people don't usually see in order to solve the integrations. That's what I can say. All right, number 10, classic one. Let's look at the integral square root of 1 minus x squared dx. So what do we do for that? What do we do for this? Trig sub is a good idea. Yeah. Trig sub is good, and in fact, you can also do integration by parts. But I don't want to be too crazy with the solutions right here. I'll just do trig sub because that's what most of my students did on the test. So I'll just do trig sub for this. Yeah, so trig sub review. So which one? We have 3 choices: sine, secant, or tangent. And the reason that we don't use cosine, cosecant, or cotangent is because they have negative derivatives. So which one? Sine, cosine, or tangent? So it's sine, secant, or tangent? Sine, that is correct, because we have 1 minus. If we have x equals, sorry, just kidding. I was thinking about the result. If we let x equal sine theta, don't ever write x is equal to sine x and then do something. No, that's not going to work. Anyway, differentiate this, we get cosine theta the theta, and let's take this integral to the theta world. Integral square root 1 minus the x right here is sine theta, and we square that, and the dx is that, which is just cosine theta d theta. Sorry about that. All right. So now let's look at this right here. 1 minus sine square theta is just cosine square theta, and then we just do the square root. So in fact, this right here is just the same as cosine theta. So you see, we actually just have cosine theta times another cosine theta, and that is cosine square theta, which is pretty good. But now, you have to know how to integrate this. So how do we integrate this? Hyperbolic substitution also work, but it depends on the difficulty, right? So if you're familiar with the hyperbolic functions and their derivatives and identities, you can go for it and try it. But anyway, how do we integrate cosine square theta? Double angle identity, very nice. We are going to look at this, and then we are going to write it as 1/2 1 minus cosine of 2 theta. And I always provide, not just usually, I always provide trig identities like this on the cover page of my exam. So my students, you shouldn't be complaining about not knowing or not remembering these trig identities. But anyway, this right here is that I just put the 1/2 on the outside because we still have to integrate this part right here, right? Okay, so now we see we have the 1/2 in the front, and let's put on the result of integration in the parentheses. Integrating 1 in the theta world, we get theta. And then integrating cosine, we get positive sign, but this is negative, so the negative stays, and we have sine. And the 2 theta stays. But because the derivative of 2 theta is just a 2, when we do the antiderivative, we have to divide it by the 2. And we can do this because 2 is just a constant. So we will have the 1/2 right here because of that. And then we're done with the integration. However, we're not done yet in the sense that we haven't gone back to the x world. So to do that, we see we have sine of 2 theta. Here we only have sine theta, right? So let's go ahead and just break it apart with the double angle identity. This right here is the same as 2 sine theta cosine theta. And we see 1/2 and 2 cancel. And perhaps let me just distribute the 1/2 before we do anything else. We can see this is just 1/2 and then times theta and then 1/2 times all this. So we still have the minus and then the 1/2, and we have the sine theta times cosine theta. Now, going back to the x world, we look at this and draw a triangle. So let's go ahead and do that real quick. We know sine theta equals x, which is the same as x over 1. Draw a right triangle. Always put the right angle here and then the angle theta here for consistency purpose. Sine is opposite over hypotenuse. So therefore we have x and 1, like this. Now, for the adjacent side, the easy way to do it is just open the square root, and we do this square minus the other side square. Always the hypotenuse first, and then you minus the other one. And when you look at this triangle, you will be able to figure out the cosine. But we also need to find out the theta. We know sine theta is equal to x. This right here means theta is just equal to inverse sine of x. Again, the inverse function property. So we have all the ingredients now. Here we have 1 over 2, and the theta is just that. So we have inverse sine x, and then minus 1/2 sine theta is just x, or if you like x over 1. And then cosine theta is adjacent over hypotenuse, which is just this. And that is square root of 1, which is the same as 1 square, minus x squared, and then we're all done. So put on the plus c and be happy. I really don't know why, but when you guys type in u sub, right? like YouTube just holds your comment for me to review. I don't know why. Like, I'll show you guys. So I have to approve that myself. I'm sorry about that. I don't know why USUB is like a preventive word for you guys to type in. I have no idea. But I just approved it. So if you don't see your comment shows up and you were just wondering like, I'm just trying to help with use substitution. Like how come how come you are not listening? It's not. It's YouTube. I don't know why. Like, I'm serious. If you type in USUB, it's just not going to show up. Like Tayyip, right? You just did USUB, right? And then again, it's not showing up, right? I will have to approve it. Maybe just YouTube doesn't like USUB. It's like USUB broke his heart before or something. I don't know. All right, so 3 more questions. All right, so especially if you are taking Cal2, hopefully you are getting value out of this live stream. And for the people who cannot join the live stream right now, hopefully later on you guys can watch the recording. Now, number 11, integral of parentheses cosine x plus tangent x squared dx. Okay, what do we do? Don't say USUB, because not only YouTube is going to block it, but also it's not the right way to do it. So let me know, but I will answer the question. Normally, how much time do I give my students for the test? Ideally, just 2 hours. You know, it really depends. But yeah, expand and use trig identity. That's it. When you have this to the second power, just expand it. USUB is not going to help right now. But if we expand it, we'll see. We do this thing square, which is cosine square x. And then we add 2 times this and that, which is just 2 cosine x times tangent x. And then lastly, we have the tangent square x, like this, so dx. Okay, so here's the deal. After we expand it, we just have to integrate term by term. This is what we did earlier, right? Very similar. So let's go ahead and just write that down. We will have to have 1/2 and then parentheses 1 minus cosine of 2x, like so. Right? We have to use that identity for this. And then for the next one, the good thing is tangent is the same as sine x over cosine x, right? So you see, this and that cancel. So in fact, the second part is just we integrate 2 sine x, which is very nice. And then for the third part, this right here, to integrate that, you can just use the identity. And that is, perhaps I'll put this down with a plus first. This right here is secant square x minus 1. So yeah, it's like a 3 detail trig identity in this question for that. And of course, the first step is the algebra. So that's the strategy for that. So this corresponds to this, and this corresponds to that, and likewise this is for that, right? And perhaps I'm just going to distribute the 1/2 right here too to make it easier. I don't want to write this down again. So it's 1/2 times 1, which is 1/2, and then minus 1/2 times cosine of 2x, just like this. And that's for cosine of cosine square x. Okay, so let's just go ahead and do it. Integrating 1/2 in the x world, we get 1/2 x. And then integrating this, we get negative, and we have the 1/2. Write it down first. Integrating cosine, we get positive sign, and then the input stays the same. But we will have to divide it by the derivative of this, which is just a number, and we just have the 1/2 like that. So that part is done. Next, integrating sine is negative cosine, so we get negative 2 cosine theta. And then lastly, for this part, integrating secant square, well, derivative of 1 is equal to secant square. In fact, that's the second question too, right? I gave you guys that already. This is tangent x, and then lastly, of course, -1. So that's about it. And perhaps lastly, we can combine this and that together, and that's about it. 1/2 minus 1 is negative 1/2, and then the x term, and then perhaps we also multiply. So -1/4 sine of 2x, and then just -2 cosine x, and then plus tangent x plus c. And then we are done. What happened? Oh no, you're talking about somebody. Let's see. Plus, not minus. Where? Let's see. Plus. Plus, not minus. Where? Where? Roger, what do you mean plus, not minus? Oh. Wait, what did I do earlier? I think I made the same mistake, huh? Oh my god. Did I make the same mistake for number 10 too? Oh my god. I'm sorry. For cosine is plus right here. Yes, and then it should be plus. And then this right here should have been a plus. I think I made a mistake for number 10 also, huh? Right? Did I make a same mistake for number 10 earlier? Because it was... I think I did. Oh my goodness. Don't like that. I don't know what to do. Oh, I'm just going to type in the description that, okay, I'm sorry for the mistake. I'm so sorry. Oh my goodness. Yeah, I didn't see anything like earlier, and yeah. I'm sorry about, so there's a little mistake for number 10 because, yeah, for this part, it should have been a plus. So earlier for number 10, when we integrate, there should be a plus in between as well. I will fix that because I plan to download this live stream and then just cut off the parts that I actually do the math, and then I will upload that as a regular video. So for that, I will just kind of add the plus sign over there. So yeah. But anyway, number 11, 2 more questions to go. Is there any other form for cosine square x? Yes, that's going to be 1 minus sine square x, right? But if you are trying to integrate cosine square, if you change to this, it's not going to be so helpful because like how do we integrate this right here, right? So that's why we use the double angle or the half angle, depends on how you look at, and yeah. Yeah, I also have a video on how to do the complex way for integrating cosine x and also sine square x and all that stuff, so you can check that out. Anyway, number 12, it's my favorite. So, you guys ready? Let's look at the integral 1 over x plus 2. Okay? Firstly, I'm going to just break down the fraction. We have 1 over x plus 1 over 2. Right? And perhaps I'll be good. I'll put down the parentheses. Next, I will tell you integrate 1 over x is ln x. And integrate 1 over 2, we get, of course, ln 2. Right? Just like that. Earlier it was x, so ln x. Right now it's 2, ln 2. Lastly, we see that we can put this and that together inside by using the natural logarithm property. So we have ln, and then we just have x plus 2. All right, done. Okay, if you guys have seen my previous video, I made that video after I gave out the test because I was so excited about this question. Okay, how many mistakes do you guys see right here? And you see, we only have 1, 2, 3 lines of work. How many mistakes do you guys see right here? How many mistakes do you guys see right here? So Gabriel say 4. I actually will say it's 5. Some people might say 6, but 5 I think it will be the correct number. 5 mistakes. Yes, Gabriel, yes. Not only each step is a mistake, but sometimes you are making like 2 mistakes in one line. So for this question, I gave students this right here. And then I told the students that there's a total of 5 mistakes, and they just had to point out 3 of them to get the full credit for this question. So it's actually a lot of fun. Alright, so let's see. You guys know how to spell mistakes, right? On my channel, misteaks, not the actual sticks. But anyway, let's see. First mistake. From here to here, of course, we cannot break down a fraction. So I'll just say 1 over x plus 2. This right here is not equal to 1 over x plus 1 over 2. Why? Because 1 plus 1 is 2. They forgot to put down a 2 right here. I know x plus 2 is that. Okay, I know, just kidding. I did the same joke already in the video, but I know. But anyway, to show this is false, you can just plug in, let's say, if x is equal to 1. Right? This is how you can just show why this is false. If you plug in x is equal to 1, we get 1 over 1 plus 2. Is this the same as 1 over 1? I don't know why I'm doing this because this is just fraction, but don't you guys miss the good old days? Like the fractions, you don't even have to study, you can get an A on the test, things like that, so let's finish that. But anyway, this is 1/3, this is 1 plus 1 over 2. Come on, this is of course wrong because this right here is 3 over 2, this is 1 over 3, so of course this is wrong. So this is how you can argue that an identity is false. Just plug in some number and then work that out. Yeah. Okay, so that's the first one. Anybody else want to go for the second one? So we go from here to here, that's wrong. And then anybody who would like to point out the second one? What's the second mistake? And by the way though, this right here is almost right? For the original integral, so. Okay, absolute value, sure. And then integral 1/2, it's not ln2, yes? Let's look at this. Let's first put this down first, yeah? Because the absolute value, integral of 1 over x dx, this right here should have been ln absolute value of x. And of course, once we get to this point right here, we're ignoring what we did from here to here, right? So if you just judge from here to here, if you look at this to that, that would be wrong because we are supposed to have the absolute value. I'm not going to put down a plus c because usually I put down a plus c at the very end. So I will just say this is the mistake for that part. And the other one is, oh my goodness, number 3. How do we integrate 1/2? Come on. ln2? Where is the absolute value? No, just kidding. I know, did the same joke again, but I'll tell you guys this right here. Integrating 1/2 is just 1/2 times x. It's just a number. You just multiply by x. That's it. So that's the third mistake. Now, what's the mistake number 4? Seven mistakes? It really depends on how you count. So right here, I have this 3, right? And then I'm just going to ignore that. And I'm just going to look at from here to here. And of course, by looking at that, this will be a mistake. First off, because I already pointed out the absolute value, so I'm not going to mention the absolute value at the very end right here. And also, if I'm not looking at this step, I'm just judging from here to here, there's technically no need to talk about the absolute value. So I wouldn't say the absolute value right here is a mistake. But if you look at ln x plus ln2, this right here is a mistake because ln x plus ln2 is not equal to ln of x plus 2. The correction should of course be ln of 2x if you ever have to combine these two ln's together, right? So that would be mistake number 4 if you just look here from here to here. Yeah. And of course, number 5, I'm just going to mention that we need the plus c. And you can say the plus c at the very end, or you can say the plus c right here, but I'm just going to say that we need a plus c, depending on which step that you would like to put a plus c, right? But perhaps the very end. So these are the 5 mistakes that I will say that this right here has. I think it's really cool. All right, so what do you guys think? What do you guys think? What do you guys think? Good? All right. Good, good, good. So this is the fun one. I'm not sure what my students were thinking when they saw this on the test. Maybe they had some fun. Or maybe it's like, they were thinking, what's wrong with this? I don't see any mistakes. Then I don't know. But actually, most of my students pointed out the mistakes, like the algebraic mistakes and also the absolute value, the plus c, the logarithm mistakes. So I was really happy. I actually have a TikTok video on that question. So I just love that question so much that I discovered it by accident. Yeah. Yeah. Okay, number 13. Number 13. Let's look at the integral 1 over square root of e to the x minus 1 dx. All right, so I will need your help. Take a look right here, and please let me know what are we supposed to do. What is the first step? What is the first step? Of course, trig sum is not going to apply here. No partial fractions. No, maybe integration by parts, but maybe kind of not really either. U sub might be the way to go. But again, Mohammed, if you put U sub seriously, I don't know why just like you two just keep blocking any comments that has U sub. So I'm going to just press on show so that it shows. I don't know why. But anyway, U sub is the way to go for this. And usually I will tell you, if we don't know how to do an integral, like especially in Cal 2, maybe just do a U sub and hope for the best. That will be my general tip for doing integrations. Unless we see the question is, of course, that you use partial fractions, or like it's really clear that you use integration by parts because of some certain forms that we have discovered, that we have discussed in the past. But anyway, for number 13 here, we'll take a U sub, let U equal the bottom, which is a square root of e to the x minus 1. Just put the U to be the whole denominator. This right here is so much easier. If you let U equal just the inside here, you are going to do another U sub later on. It's not going to be, it's going to be longer, of course. It's not going to be so easy. But this right here is the easiest way to solve this question. So what do we do next? Perhaps it's a good idea to isolate. Well, actually, no. Because if I isolate the x, I will get ln. So let's go ahead and differentiate this. So when we differentiate that, first, the derivative of a square root is 1 over 2 square root of the inside, right? And then use the chain rule, multiply by the derivative inside, which is e to the x, like so. And then as we can see, we can just multiply by the reciprocal. We get dx being equal to, this will be on the top now, so 2 square root of e to the x minus 1 over e to the x, and then du. And notice, we say this right here is the u. In fact, this right here is also u. So that's very nice. Now take this integral to the u world, we are getting 1 over u. And then dx is all that, so we have 2, and then u over, this right here we have e to the x, du. And as we can see, the u and u cancel each other out very nicely, and then the 2 can go to the front. So we have 2 integral 1 over e to the x. Now, how do we integrate 1 over e to the x? Is this from the 100 integrals? Yes. I did that in my 100 integral video, yes. First off, this is a mistake that my students make. They look at 1 over e to the x and they try to integrate that. But can we really be talking about integrating 1 over e to the x at this stage right here? What am I missing? I'm missing that on purpose right here. Because we are in the u world, very good, Roger. We will have to write down the du. So in fact, right here, we cannot really proceed with the integration step because x is not invited in the u world. So what we really have to do is go back here and isolate e to the x and see what that is in terms of u. So if you look at this, let's just square both sides and we get u squared is equal to e to the x minus 1. And then we can just add 1 on both sides. We get e to the x is equal to u squared plus 1. So now I'm going to just come back here and then we have 2 integral 1 over u squared plus 1. And then we are in the u world. So this is the step that we really have to do. Do not just integrate 1 over e to the x because we are in the u world. So a very common mistake right here that I saw after grading the test. So now we can see that this right here gives us what? That's you guys finish it. So SICK, seriously, whenever you put u sub, it's that it just blocks. Yeah. Do you guys want, if you guys want to be in a screenshot right now, just try to put u sub and then we'll screenshot. That it seriously just kind of blocks, the YouTube just blocks it. So I'll take it, yeah, hold on. If you want to be in my screenshot, like I really don't know what I'm going to see. And I'm going to make a post and you guys will see what I mean by that. So just kind of watch out my post later on. But anyway, this right here is the arctangent, which is the inverse tangent, and don't forget the 2. 2 inverse tangent of u, and u is that originally, right? So we have the square root of e to the x minus 1. And this right here, we are done. All right, so that's it, right? All 13 questions, and we are done. We are done. But wait, of course, I have a little bonus for you guys. If you guys look at the file, right? Yeah, I have a bonus for you guys, of course. We do have a question number 14. So before we go, I'll just put this down for you guys. How do you integrate tangent x? Oh my god, this is so easy, right? I know what you guys are thinking. So let's put a square root right here. And now how to integrate this? Maybe you have seen my video on this already and you have practiced this question before, so you know how to do this. And in fact, if you don't, then you can just look at my video and then you can do it, right? Okay, go ahead and try this if you would like. Integral of the 5th root of tangent x. I'm not going to add anything anymore. Anybody want to give a shot on this? Boss music plays. Yes, exactly. So if you want to have a bonus question, if you want to have an extra point, extra credit questions, yeah, there you have it. This is the one. I don't know. I'm going to leave this to you because, as I said, it's a bonus. So, yeah, that's it. What do you guys think about the live stream? My plan is to go over the exam solutions like what I did on my main channel last year. Of course, the next one will be like differential equation, also like improper integrals and all that. And then the third test will be sequence and series. And then the fourth test will be like polar equations and parametric equations and all that stuff. So that might be a good live stream schedule. It depends on when I finish the test. Usually it's about like 3-4 weeks, right? So 3-4 weeks and we'll have a live stream. But if you have any idea that if there's anything that you guys would like to see for like live stream or maybe just like a topic that you want me to talk about in a video, you can leave it in the comment and let me know. This channel is meant to be helping all the calculus students, especially Calc 2 for this semester, because I'm focusing on that. I want to build a good library of resources for my students. And you might be wondering why I don't use my old video anymore. I will have to say they are kind of old. That I think I can do better in terms of the way I present the material, in terms of my handwriting, and it's just I just want to improve. So that's why I'm not really assigning my students to watch my old videos anymore. So I want to redo a lot of things, reorganize a lot of things. So that's what this channel is for. So hopefully you guys all like it. Hopefully you guys all find value for this live stream, and hopefully you guys all have some fun today. I will see you guys next time. Right? I'll see you guys next time. Bye. And solve this.